Hey, welcome everybody. Today we're going to start talking about drawing the C-clamp. Most of this you're going to be able to work on, honestly, on your own. There's only a few things that we're really going to go over in this activity from beginning to end, or like throughout the entire process. One of them is putting threads on an object, and then the other one is going to be how we assemble something that rotates and moves at the same time. So the body of your C-clamp should be able to be drawn by you guys with really out much of my information. There's one thing that I'm going to show you in here too about threading a hole in here. The cap, honestly, which is the thing that gets put on the end of the screw, like inside of the C-clamp, can be done either as a revolution or like a series of some extrusions. Primarily a revolution would be best though, if you just imagine drawing like half of this object and then poking your holes in it afterwards. And then we have the screw itself, which also includes the handle, and again it has threads on it also. So let's talk about threads, right? Threads are the things that go either like around the outside of a bolt or inside of a nut. So in this case, these are standard threads, which means they're like a US or imperial system. The first number is the diameter of the thread. So when we say 3/8, it means that it's 3/8 from the top of the thread to the bottom of the threads. Okay, so that's its main dimension, 3/8. Then next to that there's a dash, and in this case it says 16 UNC. So 16 stands for how many threads per inch. If I was to cut 1 inch of 3/8 16 like bolts, and if I were to count the threads on that bolts, I would have exactly 16 threads for that inch. If I were to cut half of an inch of that bolt, then I would have exactly 8 threads because it's half of the 16. Okay? UNC stands for Unified Coarse Thread. The Unified Coarse Thread is a standard of threads. Okay, there's also a UNF, which stands for Unified Fine Thread. Alright, so here's a chart of different threads. Okay, and again, we either have a Unified Coarse Thread or the other is what's called a Unified Fine Thread. So let's find the 3/8, and we'll just kind of talk about the differences here. So here are the 3/8. So we have our unified coarse thread 3/8 16, which is exactly what we're using in our activity, and then we have a 3/8 24 unified fine thread. Okay, so again, both of these have a basic major diameter of 0.375 or 3/8 of an inch. But the main difference here is that there are 24 threads per inch in a unified fine, while there are 16 threads in a unified coarse. So when we're talking about bolts, the coarser the thread is, the thicker that thread is, honestly, the stronger the thread is. Okay? But when we're talking about going through like thin materials and we're talking about a nut, we really want at least 4 full revolutions of threads into that nut in order to get a good, strong connection. So if we have thin materials, then we need to use fine threads to get enough rotations within that distance. Now, in our activity today, we have a very thick area here, and we want to be able to apply a lot of pressure to this. So that's why a unified coarse thread is better, because the thread itself is stronger, and we have enough material here where we can get, we have 0.75 inches. So that's 75% of 16. So that's what, like 12... 13 threads inside of this space here, okay, which is tons. Okay, we only need 4 again. So let's start taking a look at creating threads in these parts, and we'll go from there. So I'm gonna create these screws using the Revolve command, okay, to begin with here. So the overall thickness of this thing is 1/2 inch, so from the center point up it's 1/4 of an inch. Down here again is 3/8, that's its major diameter, so half of 3/8 is 3/16. And then lastly down here it's 0.24, half of that is going to be 0.12. So when I start creating my drawings, I'm going to come up 0.25. I don't even know how far over I'm going to come, so it won't really matter yet. I'm going to draw a drop down. I'm going to draw a piece here. I'm going to draw another small drop down. I'm going to come out perpendicular, come back to the center point, and here. Remember, I'm starting on my origin. Okay, so again, the thickness between here and here is half of 3/8, which is 3/16. And then the distance between here and here is 0.12. The length of the back of this handle is 0.562. The length at the end here is 0.281. And then the overall length of this object is 3.875. Okay. So again, those are all like the length dimensions don't change. It's just your height dimensions that change, and they're cut in half. So when we go to revolve this, we want to revolve our object, and we want to revolve it around this axis, and that's going to start making the object. Okay, so let's add the thread representation to this object. This is a part of this program that's like not my favorite, but it's not too bad either. We just need to find some information out. So specifically, we need to know how long this plane is, which is what we want to put the threads around. Remember, we're going to have 16 threads for every inch that this thing is long. Okay? So without being on any sort of tools, if I click first on this surface here, and I click second on that surface there, or vice versa, it does not matter, it tells me in the bottom right corner, like way down here, that distance there is 3.0325, or 0.033, okay? So I need to know that number, 3.033, and now I'm going to select my Helix, okay, which is this button up here. So it asks me what type of face I want to go around, and I want to go around this face. And then it asks me if I want it clockwise or counterclockwise. Threads typically go clockwise, so we're going to leave it at that. And then it asks me how many revolutions we have, right? So remember, we need 16 threads per inch, so I'm going to type in 16. Then I'm going to hit the asterisk sign, okay, which is like the sign above the 8. That's the multiplication sign on a computer. So 16 asterisk 3.0325 is technically the length of this object, or 3.033 is fine as well. And basically this will do the math for us, multiply 16 times 3 and a 32nd, which is what that's equal to. And when I click the checkbox, it will put a thread around the entire piece here. Okay, so that's creating our threads. Last thing we need to do, actually there are two more things we need to do in here. We need to put our handle and we need to put a chamfer. So let's talk about creating the handle next. The handle we're going to sketch, and I'm going to do this on like my top plane. Okay, so I've created this sketch in the middle, and again we can like slice our graphic or look at this by saying section view and then selecting like where we want to section the piece at. So I'm drawing like right in the middle of this object vertically. Okay, when I look at this thing from an isometric kind of view, you can see that like half of it is seen below, half of it is hidden above. So for this part here, we're going to come to the circle. I'm going to drop this circle in here. And this hole is 0.125. No, not 0.5. 0.125. Okay. And I want this thing located horizontally, in my case, with the origin. And then I need to tell it how far away it is from the edge. So let's dimension from here to here. let's take a look at what that is. So according to this drawing here, it's 0.312 from the edge. So 0.312. Yeah, so see, it's right there, 0.312 from the ends. So 0.312, I'm going to click the checkbox, and I'm going to shift an E. And like, this isn't a hole, it's going to be an object that gets pushed out. So let's see here. I want my sketch 2 to be the thing that gets extruded. I can actually turn off my section view so I can see this thing happening. Okay. We want this to go, we need it to go like in both directions ultimately. Okay, so we can have it come up 1 inch and we'll leave it there. We're going to open up sketch 2, or not open it, but we're going to create a new extrusion based on sketch 2 again. So let me turn the visibility on for that. We're going to say shift E again. Select sketch 2 again. Except instead of having it come up now, I'm going to have it come down. Okay, and all of this is in the same part. It all gets added together. So at this point, all of these can get turned off. The very last thing that we need on this drawing is a small chamfer, which is a 1/16 of an inch chamfer by 45 degrees, which means that it's the same distance in both directions. So we're going to come back up to our chamfer tool. We just said that the distance is 1/16. It's equal distance. Click on that surface. No. 6. Yep, I guess that is right. And then there's my chamfer right there. Okay. So that's creating the threads on the handle. I'll create a new video to show you guys how to create the threads in the body. Okay, if you have any questions, let me know.